Good morning or good afternoon, everyone, depending on where you are. We're going to talk today about deep foundations, and basically into three parts. Our discussion is going to include three parts. First of all, most general information, uses of deep foundations, talking about collaborating between structural and geotechnical engineers, and then a discussion about the mechanics of deep foundations. After the Q&A session, then we'll move on to part two, where I talk about different types of deep foundations and some of their advantages and disadvantages for particular site types. I'll then go through the IBC Chapter 18 requirements for piles and discuss pile load testing. After that, we'll have another Q&A session, and I will begin part three, which is a design example. We'll go through the design of a pile foundation. Well, that is just the piles and not the pile caps, but the pile foundation for a mid-rise parking garage, and so you'll get to see application of the things that we've discussed earlier in parts 1 and 2. So with that, we'll start with part 1, and to discuss the uses of deep foundations. In the broadest sense, deep foundations are used to transfer loads from the building down to deeper competent soils. They're used where we need to reduce building settlement. In some cases, they can be used to help us resist uplift demands due to lateral loading on buildings. And in cases where we really don't have very much bearing area at the surface, we may use deep foundations simply because we're constrained with the amount of area we have. Where we have sites that are subject to consolidation, that is very young clay or mud sites, or where we have seismically induced liquefaction, then deep foundations can also be used to help us there. The thing about deep foundations is that they exist in this middle ground between the structure and the soil. And so it really requires us to collaborate as structural engineers. We need to collaborate with the geotechnical engineer. In a typical process, the geotechnical engineer will determine when they do their report that it's appropriate to use piles for a project. And the geotechnical may, at that point, ask the structural engineer, if he's already on the project, about typical foundation loads. And they'll provide a report showing what the allowable loads are for vertical and lateral. Then, based on that information, the structural engineer can determine the number of piles based on the loads and indicate the vertical and lateral requirements on the drawings. The problem with this process that is pretty much a straight handoff type process and not a collaborative process is that a lot of times there's a range of possible vertical capacities for a given site. Any given site, you may be able to use significantly higher or lower capacities depending on how deep you put the piles. And there may be a more efficient way than just picking a particular value like a 100-ton pile or something for a particular project. Also, lateral resistance is more complex than is often presumed in this basic process. And so therefore, the back and forth discussion, the collaboration is really going to be very helpful. For vertical loading, as I said, the available capacity usually depends upon the length of the pile. And it's almost never that the structural capacity of the pile itself is going to control the vertical loading requirements. And so if we understand the relationship between the capacity and the length, we can choose a length that's appropriate and a capacity that's efficient. We should realize that the cost in a pile foundation system comes from a number of different sections or a number of different elements. First of all, you have the mobilization. That is, getting the pile contractor to the site, getting all their equipment there and set up. It's basically a fixed cost depending on how many rigs they're bringing to the site. And then you have the materials and the installation time. And of course, that's basically proportional to the total length of pile. And you have setup time for at each pile and cap location and also issues about cap volume. Here's where you have a potential savings of reducing the number of piles and reducing the total cost for the project. So this kind of collaboration of looking at all of these issues can result in a more efficient process and a more efficient design of your pile foundation system.